Okay, so we're using this as our practice. We're going to start some two-step algebraic equations. I'm going to put one on the left in black, which is going to be your easier of the two, maybe a grade 7 or grade 8 question. And then I'm going to put a slight variation on the right in red, which is a grade 9 version. And I won't go too complicated, but I will go a little bit harder. But as long as you get the idea of how both work, you should be able to do both anyway. But we'll just practice them. Here we go. Try those two questions. Okay, so hopefully you press pause, you tried the questions, and now you're going to see if the solution is correct. So in the first question in black here, we have a coefficient of 2 and a constant of -4. When we isolate the variable, we were told in two-step equations to get rid of the constant first, which means your first step will be to add 4 to both sides. Your new equation will be 2x equals 10, at which point you will divide both sides by the coefficient and isolate the variable to solve it, giving you the solution of x equals +5. In the grade 9 question, which is really technically a grade 8 question, but we'll just go with it anyway. Add 4 to both sides to get rid of your constant. -2x equals 5. At this point, you're going to divide both sides by -2. And your solution is going to be -2.5 or -2.5. All right, here's two more questions. Try these ones. All right, so you press pause, you tried the questions, let's see if your solution is correct. In the first question, our constant is +1, so I'm going to subtract 1 from both sides to create a new equation that is still equal but does not contain a constant. And that equation will be a -1/2 of x equals 4. I'm then going to multiply both sides by -2 to get rid of the -1/2, because if you multiply a -1/2 by -2, you get 1. And our solution will be x equals a +8. If we look at the second question, the only difference is normally usually we have the variable term first, the constant section, and the equivalent value third. That's usually how a standard equation looks. Here, our constant's actually first. So our -2 is our constant. We're going to add 2 to both sides. Now, please make a mental note somewhere. A -1/4 of x, that is called a -1/4 of x. I could write it this way. I could write it this way. Oh, sorry, not that way. Or I could write it this way. Andrew, of the three methods, which one do you think we're going to write? The first, second, or third way? We are indeed going to write it this way here, and I'll tell you why. When we rewrite this equation as this, it allows me, on my next step, to multiply both sides by -4 to isolate the value of x, right? Meaning x equals -12. If I wrote it this way here, I'll just go back in time for just a second here. If I wrote this like this, then the problem is, by multiplying both sides by 4, I still have a coefficient. What is my coefficient? -1. So I'd have to add another step, and I'd actually make it into a 3-step equation, right? X equals -12. So if you take the time to realize that if you put your negative symbol in the denominator, it does make the isolating of the variable easier to do, right? Okay. Try these two questions out. All right, let's take a check. Actually, you know what? Question 1, the black one, is actually harder than the red one, I think. So the first thing you need to know is your 4 is your constant. So subtracting 4 from both sides, just like this little thing here, subtracting 4 from both sides maintains equality, but creates a new equation. Oh, we have that same thing we had last time. How do I want to write this? X over -2 equals a -3. That's the equivalent equation. Multiplying both sides by -2 will maintain equality, but we'll create an equation of x equals a +6 for a solution. In the red equation, 2.5 is my constant, so I'm going to subtract 2.5 from both sides. A -1.5 and a -2.5 makes a -4, so my equation is 2x equals -4. Divide both sides by the coefficient of 2, and x will equal -2. All right, let's practice 2 more, and then we'll be done. Go ahead and try these 2 questions. Okay, So we look at these two questions. The black one is a grade 8 question. The red one is a grade 9 question. In the black question of grade 8, our constant is 4 because it's on the same side as the variable. So we're going to subtract 4 from both sides to end up with 2 equals negative 2x. Then I'm going to divide both sides by the coefficient of negative 2 to have a solution of x equals negative 1, or negative 1 equals x. In the second question, the red one, we're going to identify the constant as a half. So we're going to subtract a half from this side to get rid of it, leaving you with negative 2x. But over here, subtracting a half from both sides becomes a fraction question, which requires a common denominator, which requires equivalent fractions, which ends up with a solution of 1/10. I'm then going to divide both sides by the coefficient to isolate the variable x. But when I divide by a negative 2, in grade 8, when you learned about division of whole numbers, you learned the easiest way to divide fractions is not to divide, but to keep the first fraction, change to multiplication, and use the reciprocal of negative 2. And the reciprocal of negative 2 is the flip, which means it's a negative half, right? When you work that out, you're going to get negative 1 over 20, which is your solution to the second question. And finally, your last questions. Ooh, that red one's a good grade 9 question. If you can figure it out, you're well on your way to doing well in this chapter. Okay, you pressed pause, you tried them, you did your best. Hayden, what did you do first in the black question? Added 2 to both sides is correct. In which case you end up with negative 2x equals 0. Dividing both sides by negative 2, x will equal 0. 0 divided into any number of groups, regardless of what they are, will always be 0. In your next question, you're going to subtract 1 3/4 from both sides. When you subtract mixed fractions, it's easier to change them to improper. Then find a common denominator. Then find an equivalent fraction. Now remember, when we did this in the first of the year in September, you want to, first of all, keep this side here like this. Keep your denominator, subtract your numerators. Your answer is going, oh, sorry, your numerators. Your answer is going to be negative 34/20. Now, if you wanted to, you could change that to a mixed fraction, but we're going to still utilize fraction sense here. So I'm not going to change that to negative 1 14/20 or negative 1 7/10. Because right now, I am multiplying x by 2/5. If I want to get rid of a multiplier of 2/5, what do I have to do to both sides? I have to divide both sides by 2/5. That gives rid of the multiplier. Dividing by 2/5. The easiest way to divide by 2/5 is to multiply by the reciprocal, which is 5 over 2. Smart human beings right now will realize they're multiplying two fractions together, and they'll hear their teacher's voice in grade 8 saying cross reduce. And if you cross reduced, you ended up with a solution of negative 17/4 or negative 4 1/4.